4 question. There's only going to be one of them. It's worth 6 points, the part 4 question. Am I going to guarantee it's a proof? Absolutely not. It could be a tricky density problem for all we know. Okay. Last couple of exams, has it been a proof? Yes, but don't assume that, please. Okay, don't assume. Part 4, 6-pointer. Here comes the big dog, the proof. Don't get in that mindset. So here we go. It's been a while since we've done proofs. I'm just looking at the proof statement right now, and I'm thinking to myself, FG congruent to EG. Probably not going to happen unless what's congruent first? Triangle. So I'm thinking this is probably going to be a CP-CTC proof, right? All right, prove the pair of triangles. So which pair are we talking here? Well, whatever pair contains FG and EG. Those are full sides and only 2 triangles I see up there. FGD, BGE. All right, so I'm going to try to prove those 2 triangles congruent so I could say CP-CTC. All right, without even looking at the givens, what can you say right away? Without even knowing anything about this diagram, what can you say is already true up here about those 2 triangles? Let's start it off right today. 16, what can you tell me is true? Vertical angles are congruent. So at least I can say angle BGE is congruent to angle FGD. If you guys want to keep track of what you have, because you don't know how long this proof's going to be, put a little A next to it. You got 1 pair of angles. Vertical angles are congruent. All right, now I got to rely on my given. So let's roll. Angle ABG, which is this one right here, is congruent to CDG, this one right here. AB is congruent to CD. And wow, they give you a lot here, don't they? And CE is congruent to AF. Whew. All right, let's do this. They still don't give me any sides or angles in those 2 triangles I need. So right now, all I have is a pair of angles. All right, we have a lot of places we could go here, I think. A couple different ways to do this proof, if I remember. Which way do we want to go? Let's see, I'm trying to think. What's the best way for us here? You got the pair of angles. I could prove it this, and then I could say those 2 are equal. Oh, I can do those. Yeah, okay. Let me start by these 2 angles right here. These 2 angles being congruent to each other. Anybody know what I can apply then? What about side BA and CD? Jonathan? They're parallel, yep. And I'm just going this way. This is the first way I saw, so I'm going with it. BA parallel to CD. Jonathan, what type of angles are they? Congruent, alternate, interior angles means I have parallel lines. All right. Notice in the givens, it just said it was a quadrilateral, so I can't prove any properties yet or use any properties. But Jonathan just proved BA parallel to CD, and they were given congruent. What do I have now? Now what is it? Parallelogram. Anybody remember the special case? 1 pair of sides congruent and parallel means I have a parallelogram. So 1 pair of opposite sides congruent and parallel implies a parallelogram. Now, now I can use any of the properties of a parallelogram too. Right, now I can use any of the properties. First property being, everyone ready? What do I know about BC and AD? If that's a parallelogram, what do I know about BC and AD? 2, BC and AD. Okay, I'll start there. BC is congruent to AD. What property did you just use there, Matt? Parallelogram implies? Anybody seeing why I'm going to need that property? Because it was given AF and EC. Do what with the 2 to get a side in my triangles now? 18, what can I do with the congruent parallelogram sides and the congruent given segments? Good work. Subtraction. So I can say AD minus AF. Sorry about the sloppy writing, but I want to get through this. BC minus, what is that, EC up there? Subtraction. Still holds true. If you write subtraction or addition, very next step is going to be substitution. To say side FD congruent to side BE. Okay. I got a pair of angles, got a pair of sides, need one more pair of something. I asked Matt before a couple minutes ago what he knew about BC and AD. He chose to say congruent, which was true. But they're also what? They're also parallel. No, they're not parallel. Well, they're also, yes, they're also parallel. So BC parallel to AD. And I'll just finish this up by word of mouth now. If those are parallel, why are these angles right here congruent? Why are those red angles congruent if BC and AD are parallel now? 7. Parallel lines imply alternate interior angles congruent. And then finally, what method do I have now that says these two triangles are congruent? What method have we just proven as a group? 11, what method do I have up here? Angle, angle, side, CPCTC. Thank you for my 6 points. The only other way I was looking at it here, everyone all right the way we did it? Prove it's a parallelogram, use properties. All good. Eva, you good with that? I know it was your question. All right. Another way we could have done it, I think we would have had enough information is, let's see, what did we have? This right here, right? We had this. You could have proven the two big dogs congruent here. Said BD was reflexive, right? BD was reflexive, and then you would have had side angle side. And then I'm trying to think here. You could have said CPCTC, this angle was congruent to this angle. You had your vertical angles. What else? Oh, you could have used AD and BC being equal by CPCTC, then the subtraction we use similar. All right, so you could have proved the two big triangles congruent. One thing that probably may have come up or might have come up if you're given this in 3 weeks. Remember, we proved it a parallelogram. Why can I not say diagonals bisect each other to get FG congruent to EG? Tammy? What's up, Griff? It's not even a diagonal, right? Diagonal's got to come from vertices. So that's out of the question. All right, Eva, good? Okay. Charlotte?
Can you go for the second part of 34?
Yep. Let me go through, actually, you know what, you asked the question, so I'm not even going to bother. The first part here was basically, if anybody hasn't done this yet, these two have the same volume. They can hold the same amount of almonds. They have the same volume. This one has a height of 16, and they want to know one of the base sides. So we use the formula volume equals BH. Find the volume of the cylinder, plug it in for V. Plug in 16 for H, solve for B, which is the area of your square base, and then take the square root. And I think, what was it, 13.2? If I remember from this morning. 13.2. Okay, so that's the answer to part A. All right, look it up if you need some help with it. But that's the gist of it. Solve for capital B and take the square root. Now the question, and the second part's a beast. And lucky for you guys, this is my second time through it, so I have different ways of explaining it than I did in period 2. We got this shelf here. Okay, we got the shelf. We're going to put the chocolate-covered almonds on there, right? I mean, the rectangular prism one, not the cylinder one. So we're going to put these bad boys on my shelf. Again, 16, 13.2, 13.2. The shelf is 80 centimeters long and 60 centimeters wide. How many of these can fit on the shelf? And remember, the shelf can only have one layer, so I'm not stacking them. Okay, one layer. Square base, right? Square base. 13.2 by 13.2. So here we go. We're going to pretend my little post-it notes here. 13.2 by 13.2, right? There's one. 13.2, 13.2. $13.2. Hopefully after this one, you see where I'm going with this. 13.2. How many cans can I fit going this way? How can you find that out? How many cans can I fit going this way? 80. What can I do with the 80 and the 13.2? 80 divided by 13.2. Everyone go ahead in your calcs. 80 divided by 13.2. And it's asking me for minimum amount. So what's the minimum amount I can go going this way? 6 cans going that way. And then what about stacking them behind? 60 divided by 13.2. How many can I stack behind? 4 of them, right? So let's think. How many cans can I, or how many prisms can I stack in here? Well, I can go 6 going this way, and each one is 4D. 6 post-it notes across, 4D. So I can end up with how many containers? 24 containers. Okay, using that square base of 13.2 by 13.2. Everyone see how this goes? Charlotte, how'd that look?
Yeah, why can't you just take the volume of the shelf and divide it by the volume of the containers?
The volume of the shelf. Well, the shelf's only a rectangle. That's the shelf doesn't have any like depth to it. It's just length and width. So there is no finding the volume. You're talking about a 2-dimensional object versus a 3-dimensional object here. Okay? Just think of it as, your desk right here. 60 by 80. And then how many of those can I place on your desk so it fits in?
Okay.
See what I mean there? Okay. What's up?
I don't understand why you couldn't do it like you multiplied 60 by 80 and then you did 13.2 times 13.2 and then divided that. Because when I did it, I got 27, and it doesn't make sense to me because like you're doing the area by the area. Is it
I gotta think about that a little more. I'll get back to you.
My only guess would be because like it's not going in rows and it's just like being divided by the area itself. But I just don't understand why that couldn't work.
Let me think about it. Okay, let me think about it. Other questions from the homework? Those are great questions. Mahmood, let's go.
The explaining part of 32.
Did you show work on 32?
Yeah.
That's usually what the explain is. Oh, here? Prove it's a...
It's like you do like distance formula for all of them.
Yep.
Then you get square root of 50.
Okay, so here you go. So remember how these are going to be set up if you have to do a coordinate geometry proof like this one is. Just like you would do in any proof, except no statements reason. So number 1, you said distance formula, right? So NA, AT, TS, SN. Showing me all the distances. What do they come out to be? 50, radical 50? Okay, so you throw your numbers in the distance formula, square root of 50. I would highly recommend you don't try to be a hero and break it down, because if you do get it wrong, we got to mark it off. This is fine. This is fine. Now, number 2, what'd you just do? What did you just find? All of them came out to be square root of 50. So what did you just find for yourself?
They're all
Okay, so NA congruent to AT, congruent to TS, congruent to SN, because all distances are equal.
but that's like all the
Well, I'm not done yet.
yeah, I know, but that's what the video had and like,
Yep.
like the answers he had. So don't we have to like do it like a parallelogram and then on this?
You could, but if you want to get to it right away, you can just show all 4 sides congruent. If you want to do parallelogram with 2 consecutive sides, that's fine. There's multiple ways of doing it.
No, I'm asking,
This is
like,
probably the quickest way.
like when you explain it out, you have to say that it's a parallel.
No, I don't. Don't say that, because you never did. You never said it was a parallelogram. Now here you're going to say NATS is a rhombus because all sides equal. It's guaranteed. If you can show me a quadrilateral with all 4 sides equal, it's guaranteed to be a rhombus. Maybe a square, but guaranteed a rhombus. Okay? Yes, Griff, go.
Wasn't it we said that diagonals were perpendicular?
Okay, you got to show it's a parallelogram then. Okay, got it. Here's why. Say I have a quadrilateral, because all we know right now, Griff, that this bad boy is a quadrilateral, correct? So if you just proved only that the diagonals were perpendicular, it'd still be a kite. I need to eliminate that possibility by showing it's part of the parallelogram family. Okay? Good question. Good question. Yes, I need to, if in that case, prove it's a parallelogram first, then you can do perpendicular diagonals. But in your case, still might be a kite. Yes, Eva.
So, like, to do that, would you have to find the slope of all of the sides and then just say that?
To prove a parallelogram,
Yeah, to say that.
you could do slope, all 4 sides, distances, show opposite sides congruent. You could show both diagonals have the same midpoint. That proves they bisect each other. A lot of different ways to show a parallelogram. Okay? Great questions here. Great questions. Keeping me on top of my game. And let me tell you, I'm on fire today, by the way. This is unbelievable, this discussion we're having. Other questions? Let's go, Charlotte. What do you got for me?
With the same question.
Yeah.
If you said that all the distances were congruent, and then I thought that I needed more, so I also said that the diagonal is perpendicular. Do I have to say that it's a parallelogram, or can I just say
Depends on your reason for a rhombus. If you're going to say Nats is a rhombus, what's your reason? Depends your wording now. It's going to depend on your wording. If you just say diagonals are perpendicular, no go. But if you say all sides are congruent and diagonals are perpendicular, that's fine. You just threw in a little extra. But you got to say those sides are congruent. Okay, just the diagonals being perpendicular doesn't make it a rhombus. Anything else? Keep feeding me. Anything else? Paul, let's go.
If you prove all sides congruent, what would the difference between like?
There's no other quadrilateral out there that you can say has all 4 sides congruent other than a rhombus and a square.
Yeah, that's what I was thinking.
So that's why showing all 4 sides congruent, good enough to call it a day in a rhombus. Because there's nothing else out there that has that. Rectangle, nope, trapezoid, kite, they don't have all 4 sides congruent. All right? And I don't care about a square because I was asked about a rhombus. All right? If I was asked about a square, then yes, for all 4 sides being congruent, I need a little extra now. Probably a right angle thrown in there. Others want to keep discussing anything else? Anything else from January 2020? Because that's a wrap. We're done. Anything else? All right, you ready to move on to January, what did I say, August 2019? And hey, yeah, I know it's hot, but guess what? It could be this hot in the gym or the cafeteria in 3 weeks. Cannot guarantee. Also, while I'm getting set up here, the Monday before our exam, you guys may or may not know we do not have school that day. The Monday before our exam, I am still planning on coming in here for a few hours and holding a review session. All right, just to put that on your calendar. Probably too. Got to see what my social calendar looks like because dad life. that Saturday before 2, I'll probably be stopping in here for a couple hours to review as well. All right, Charlotte.
Sorry, I have one more question on January.
Yep, no problem. I don't have many, and they're not that great, but styluses. I don't have that many, and they're not that great. All right, but I do need them returned. Charlotte, go.
On 31, in the videos, I had the same answer, but on the interview I didn't, and I put it in like life is understood speed.
Yeah, so that's fine. They probably put it in point slope form.
Yeah.
That's fine.
Okay.
Point slope. Unless it's specific, sometimes it'll say leave your answer in slope intercept form, which is what you have, y equals mx plus b. But most of the time, it can be slope intercept, point slope, which is probably what you saw in the answer key, or you can have the x's and the y's on the same side and number on the other. Yeah, that's fine. Unless it specifically says, it doesn't matter. Anything else before we go August 2019? Ready to roll? My suggestion tonight, we're going to go through as many as we can right now that I have selected. My goal for tonight, get the multiple choice done. Okay, get the multiple choice done in August 2019. All right, that's the goal tonight, get the multiple choice done. You are going to start seeing repetition of material, of topics that we talked about those 3 days last week. When I'm up here talking to you guys, the problems I selected, I don't think they're tough. I don't want to try to make your life miserable than it already is in here. My goal is I pick problems that we've never talked about before. All right? I'm not going to pick problems that we talked about last week for those 3 days of common topics that come up on the exam. I'm picking questions that probably we haven't sniffed yet. All right, and I want to give you a taste of it because they are common ones. So the first one's number 12. All right, first one's number 12. What is the area of that shaded sector? We're not doing the problem unless we know the formula. Cold hard fact sheet, or you can get it jotted down right now in the sheet I gave you Friday, because it's not a formula sheet. It's not a reference sheet formula. So here we go. Area of a sector. Area equals measure of your arc over 360 times the area formula, pi r squared. That is the area in degrees, because I know there's a radians one, in degrees of a sector. So to, again, have any shot at this problem in 3 weeks, got to know the formula. Second way to have a shot at this problem, read it carefully. Everyone see they gave you 120? I'm not using it in the formula. It said shaded sector. So I'm not plugging 120 because that's not the degree measure of that arc. How do I find the degree measure of the shaded arc there? Come on, sweat is dripping here. 16. 360 minus 120. So I'm going to be plugging in 240 over 360. And the rest is cake now. Times pi 9 squared. Just pay attention. Everyone see what the answer is in. Answers are in terms of pi. Hey, legit. Hey, seriously. Are we okay leaving answers in terms of pi? And what do I need to do in my calculator? You shouldn't be touching the pi button. But multiplying everything else. 21. When you're ready. 10. When you're ready. 54 pi. Done. Anything else you want to add on to that? Area of a sector. Serena.
I have a question.
Yep.
Which formula is measure over 360 times pi d?
Length of an arc. Length. So if I asked for the length of this from A to Z, A to C, what's the length of that arc? This would be pi d instead. Yes, pi d. Same exact formula except circumference versus area. Great question. Anything else I can answer? All right, next up, 15. We haven't really gone over one of these type problems. Oh, good old Chelsea, sitting 8 feet from a tree. Oh, there's a little vocabulary. Angle of elevation. Probably going to use what here then? SOHCAHTOA. All right. When we did angle of elevation and angle of depression, they were always in a right triangle. And is that the one looking up at something or the one looking down, elevation? Is Chelsea looking up or looking down here? It says to the top of the tree too, right, Jonathan? So we would assume looking up, yes? Looking up. But here, whoa. Her eyesight, her line of sight starts 1.5 feet above the ground. So when I draw this right triangle in, when I draw this right triangle in here and I put 36 degrees, remember, the line of sight here starts 1.5 feet above the ground. We're not on the ground. And everyone see where the tree's going to be. On the ground. The trees don't float on the Regents exam, unfortunately. So there it is. There's the tree. And the 8 feet, she's 8 feet from it. Good old Chelsea. Think she goes by Chelsea or Sea Dog? Probably Sea Dog. Sea Money. How about finding the tree? How can we get to the tree? Because I see a right triangle here. I don't know how much it'll help me, but I don't think it'll get to the final answer. Hey, I need a plan of action from you. Plan of action from you two. Matt, plan of action. Let's roll. I got to find the height of the tree. But the tree's not part of the right triangle, is it?
No.
All right, so I'm just not going to do one SOHCAHTOA and be done here. Is there something you could find as far as the right triangle goes, then help me get the tree?
You could find the opposite side.
And do what at the end to find the tree?
Add the height under.
There you go.
1.5.
Yep, add the 1.5. All right, what are you going to use to find that opposite segment? Sine, cosine, tangent. Which one here? I'm not even going to ask the sides anymore. 6. Tangent. Tangent of 36 equals x over 8. Cross multiply. I love this problem so much. Love it so much. It just proves my point that I've been barking about all year long to you. I'll show you my point in a second. Matt said add 1.5. He's correct. So to the nearest foot, it ends up being 7. Nope. 8. 7. About 7 feet. Yeah. Here's the point. I've always told you not to do what? To this number here, because we're not done with the darn problem yet. Don't round it, right? So let's think you're a hot shot. I don't need to follow rules. You round that to 6. To 6, add 1.5, and get 7.5. What are you circling? 8. That's why we don't round to the end. Thank you. All right. Regents exam for proving my point. Did you see that, Brendan?
Yep.
Darn right. Score prediction. What do you got?
Obviously 100.
Yeah, right. That's how we think around here. Good. What are you going to get for it?
I have no idea.
Think about it. Anybody else? We good? All right, let's go. Wow, it is pretty warm here. 20. Let's see who, period 2 got this one. Let's see if you're at the same level now. 20. There is a phrase in number 20 that tells me exactly how I'm going to do this problem. And that's why I picked it. There's a phrase here. Here's the phrase. Altitude is drawn to the hypotenuse. Altitude drawn to the hypotenuse. Before I draw the diagram, anybody know it's going to pop up here? Ooh, nice job. What is it going to be? Hills and Sass, yes. Anytime I'm drawing an altitude and a right triangle to the hypotenuse, always going to be hills and sass. All right, let's see what. Can you draw your own diagram here? And then we'll talk which one and what's my proportion look like. Altitude TV, so that T must be the right angle. V must be up here. R and S doesn't really matter. RV 12, RT 18. What about SV? Okay, which one do I use? Simple question. Is the altitude involved? Is the altitude TV involved at all? Do you have a label on TV? How about that question? Do you? Then I guess we're not using what then? We're not using SAS. Darn, altitude's not even labeled, so it's got to be hills. Ooh, here we go. Refresh here. 22. What's the H stand for in hills? Okay, where is it? Name the segment that represents the hypotenuse. Great, RS. Hypotenuse of the large right triangle. What are you plugging in for H then? 20. How long's RS? Thank you. 12 plus X. What's the L stand for here? 20 again. Legs, which now is what? 18. Other legs not even labeled. Who cares about it? Are the legs the same in hills? Yeah. Remember, the means are always the same. Hills and sats. Here's the big one. What's S and which one do you pick? Ho, 4. What's S stand for, Griff?
Segment.
Which one? I got 2 of them up here. I got 12 and I got X.
X. Is there something?
No, don't give me that baloney.
12.
The segment next to the leg, right? We're using. What leg are we using?
18.
What's the segment adjacent to it?
RV.
Which is?
12.
That's the one we use. Okay? You use, and I bet if you plugged X in, that number's there somewhere too on the choices. All right, go ahead, cross yourself up. Let me know when you get a value out. 14. We don't have one. 16. When you're ready.
15.
X may not make you a winner. Please, 2 hours. You can stay for 3. A lot of quality time together. What is the length of SV? Okay, I labeled SVX. That is my answer, 15. It might have said, what's the length of RS? And then I would need to add 12 to it. Altitude to the hypotenuse. Hills, SAS. You good? Yes, we're all set? All right, let's keep grinding away. Multiple choices here. 23. Which one of these 4 carries the rhombus onto itself? Meaning, everyone see the rhombus we see here? Which one of these 4 would make it the same looking rhombus in the exact same position, not moved at all? How about 180 degrees rotation about the origin? Would that result in the same rhombus I'm looking at? The answer would be no. Here's why. Take that vertice right there. 180 degrees. What quadrant would it end up in? 90, 180. It end up over here, and it's not. I don't have any point there. So everyone see why that one. Woo! See you later. What about a reflection over 1/2 x plus 1? I don't know. Let's see. That's going to be here. Up 1 over 2, down 1 over 2. What do we think there? Would that carry it? onto itself? Or is somebody going to see an issue here? Anybody? No? We're just going to stare. We got 6 minutes of staring. If that's going to work, if not, why not? Go ahead, Serena.
It wouldn't work because if you create the point like closest to the right up, it would be
What do you? This one?
no, the one on the right.
Okay.
Yeah, that would go. It would be like on the point.
You're not. Yeah. Here's the thing. Like, it's not. This point isn't flipping over this way, is it? Like, you got to think about. I know you can't fold it because you're on your Chromebooks, but if you think about taking this and folding it over, we're not matching up here. Okay, we're not going to match up. All right, and that's a problem. You got to fold it, the whole thing over the line. You just can't go, oh, that one goes through that point, so that ends up here. Great job. Here's why I think this problem is tough. You could eliminate one easy. Two, we had a little bit of an issue with. Here's the problem. What the heck is y equals 0? Y equals 0. That's a fancy name for what? Y equals any number is what type of line? Horizontal. And 0 would make this basically what? Reflected over the x-axis. X equals 0 would be the y-axis. One of these true? Which one? Flip it over the x-axis? Y-axis, x equals 0. That's why I think this problem's tough. That's why I picked it. Because you got to know what axis they're talking about, y equals 0 and x equals 0. Remember, x equals vertical. I don't know, maybe x equals, that's a vertical line. Y equals, I should put a number here. Horizontal line. Now I'm going to get in the part 2 section. I think I have time to do this one. Go ahead, 28. Go ahead and graph that triangle real quick. 28. Yeah, sorry about the exterior angles on mine. Yeah, this should be a free 2 points for all the honors kids. Free 2 points. Area formula. 1/2 base times height. Can you guys see an easy base and height you can calculate? There's 3 of them, right? There's 3 bases and 3 heights in every triangle, depending on where you draw the height. But do you see an easy one to count? Right, AB. 1, 2, what am I counting? Just look. 8, 10, 12. 12 times the height, C, perpendicular all the way down. 1, 2, 3, 4. Is that 5? 5? Yes? It's not the reason I did it, though. I'll be honest. It's not the reason I did it. The reason I did it, I want to keep reminding you. The one thing that never fails on find the area of something on a graph, no matter if I know the formula or not, if I can count like I could here, something that never fails, the box. Find the area of the box. Of course, find the area of the box, and then I'm not even going to waste time anymore. The two right triangles. Okay. All good? All right, so I'm suggesting the rest of the part ones. I'll answer any questions you have tomorrow, and we'll start digging into part 2 and 3 of this exam. All right, so we're still working on this exam tomorrow. Good work today. Good work. Take any of the stylus back, please. So Saturday and Monday before the test.